I guess.
Have you ever littered?
Yes, I have. But when I was taught the lesson of protecting Mother Nature, I quit littering.
What can you do to help prevent pollution?
Reduce and reuse whatever I can to eliminate the amount of waste is what I can do to prevent pollution.
What does the government do to encourage people to protect the environment?
They organize some campaigns to raise the awareness of people. Everything should start from education.
Are people in your country aware of the environmental issues?
Yes, they are. They care about what happens to the environment around them.
Is there any law to enforce people to protect the environment?
Yes, the environment law states punishments to people doing harm to the environment.
Hey everyone, welcome back to Understanding Motors. Last episode, we discussed how running current through a wire which is situated in a magnetic field can create a force on the wire, and then how, if we make a loop out of the wire, we can create a net torque on that loop. Let's start by exploring this idea a little bit more. As we said last time, the torque on this wire can be quantified as the cross product between the distances the forces are apart and the force vectors themselves, where the force vectors are the result of the current times the length crossed with the magnetic field. Now I know that all these cross products can make this a little bit less intuitive, so let's make some simplifying assumptions. If we assume that the magnetic field and the direction of current are perpendicular, as shown here, we can reduce this cross product of IL and B to simple multiplication, where the resulting force will, for the case shown here, point up and down. For the second cross product, we can use the fact that the magnitude of a cross product is equal to the vector magnitudes times the sine of the angle between them. Noting that our force vector will lead our current vector by 90 degrees, we can approximate our earlier equation of torque to be equal to DILB cosine theta. Looking back at the animation we showed last episode, we can now plot the torque on the loop as it swings through a revolution. From this, I want to point out two key ideas. Firstly, the torque is maximized when the coil is directly in line with the magnetic field. Another way to say this is that the torque is greatest when the magnetic field induced by the wire is perpendicular to the external magnetic field.